Hey guys, this is the final review for the 16-17 school year. This is the Algebra 2 Honors version. And the problems that we're going to be looking at here are based on rational exponents and radicals. Specifically, if you're using your book to help you review, that's Chapter 6. And those are problems 1 through 3, 13, 34, 35, and 36. Hey guys, this is the first part of your final review. This is going through the problems from Chapter 6 in the book. These are related to radicals and functions. First up, we've got a graph, a square root function, and this is the graph of y is equal to the square root of x plus 4. If you wanted to, you could make a table of this. You could figure out which one of these fits the table of values. You might also recognize that a plus 4 on the inside means that we're moving this to the left 4 units, which gives us b as our answer. Next up, we've got the equation, the cube root of the quantity x minus 4 is equal to 4. To get rid of that cube root, I've got to cube both sides. And in doing that, we get x minus 4 is equal to 64. To finish solving this, add 4 to both sides, and x is equal to 68. Since this is multiple choice, you could also have plugged each of the answers in to see which one works. For number 13, we're looking at finding the inverse for a linear equation. I'd like to remind you the procedure for finding an inverse is we're going to switch our variables. So this becomes x equals, let me make this a little bit smaller, x equals 6y plus 3. We're going to subtract 3 from both sides to get x minus 3 is equal to 6y. And we're going to divide both sides by 6 to get x minus 3 over 6 is equal to y. That's our answer. And in looking, that appears to be choice B. For number 41, we're looking at a cube root equation. In order to start this out, the cube root is already by itself. So I'm going to cube both sides. On the left, I get x minus 5, and on the right, I get negative 27. When I get the x by itself, we're going to add 5 to both sides, and I get x is equal to negative 22. That's my final answer. For number 42, I'm looking at a cube root equation. Since the cube root is already by itself, I'm going to cube both sides. On the left side, we get y minus 2, and 5 cubed is going to be 125. To get y by itself, I'm going to add 2 to both sides, and I get y equals 127. For number 43, we've got a square root equation. Since the square root is already by itself, I'm going to square both sides. This should actually be an 11 on the right side. When I square the left side, I get 2y minus 7, and when I square the right side, I get 121. To get the y by itself, I'm going to start by adding 7 to both sides, and I get 128. On the left, I get 2y. When I divide by 2, I get y is equal to 64. Here we're asked to simplify an expression involving a cube root. What I'm going to do is break this up into 2 different pieces. We're going to have the cube root of 64 multiplied by the cube root of b to the 15x power. We're going to handle these 2 different ways. The first is because the cube root of 64 is a number. It comes out nicely. And if I were to factor 64, what we're going to see is that this is going to be 8 times 8, or 2 times 4 times 2 times 4. If I were to combine those two 2's, we get the cube root of 4 times 4 times 4, which is just 4. You also have access to your calculator, so you feasibly could type in the cube root of 64 and get 4 as your answer very quickly. The second part of this I'm not as good at because the variables here don't play well in my head with those exponents. I might use the idea that a cube root is the same as the 1/3 power. And when I do this, I might be able to see that I can use some exponent rules, and these guys multiply together. 15x times 1/3 is going to be 5x. That'd be b to the 5x for that second piece, giving us 4b to the 5x as our final answer for this problem. We got to do some function stuff. In terms of this, we've got f of x equals 9 minus x squared, and g of x is equal to 3 minus x. We've got to find f of x divided by g of x. And in doing that, I'm going to get 9 minus x squared over 3 minus x. In this case, you might recognize that 9 minus x squared is the difference of two squares, which is 3 minus x and 3 plus x. So to finish this up, we can do 3 minus x on the bottom. And what you might notice is that the difference of two squares parts lets you cancel something out, so you end up with 3 plus x as your final answer. Here we've got some composition of functions. We're given r of x and s of x. We've got to find r of s of negative 3. What this means is just we've got to plug negative 3 into s. Whatever we get as an answer, then we're going to plug into r. So s of negative 3 is equal to negative 3 cubed minus 4. Negative 3 cubed is negative 27. Minus 4 is negative 31. Now that I've got negative 31, I'm going to plug that in to function r. And that's going to be negative 31 squared plus 2. I'm plugging this in for x. Negative 31 squared is negative 961. Plus 2, we get a final answer of negative 959. 47 through 49, we're finding inverses based on points. I'd like you to remember that for an inverse function, we are just swapping our x and y coordinates. We're doing the same thing as though these were tables. In fact, you could set this up as a table, and the points would be 1, 7, 2, 5, 3, 3, and 4, 1. And on spirals, what we did was we swapped these to get an inverse function of 7, 1, 5, 2, 3, 3, and 1, 4. You didn't even have to necessarily make the table. You could have just swapped those points. For 48, that's what I'll do. Instead of 1, 5, we have 5, 1. Instead of 2, 3, we'll have 3, 2. Instead of 1, 3, instead of 3, 1, we'll have 1, 3. Instead of 4, negative 1, we'll have negative 1 and 4. I'd like you to notice that none of these points change signs, they just change order. And finally, for 49, we have a bunch of ones that have the same points. In fact, those don't change at all. Because if I switch 1, 1, well, it stays 1, 1. The same for 2, 2. 1, 3 is going to become 3, 1, and 4, 4 would stay the same at 4, 4.